So we're simplifying each of these, and each one has maybe a slightly different flavor for us to figure out and deal with. So on this first one here, you'll notice that all we're doing is adding and subtracting. So the only thing we can do is look for like terms. In this case, we have two like terms. We have an x squared here, and we have an x squared here. So I'm going to be able to add those. Everything else stays the same, so it's still going to be 5x cubed. And then negative 8x squared plus 2x squared. That's negative 8 plus 2, that's a negative 6. So I do minus 6x squared. Then the minus 5, there's no like terms with that one, so it stays the same. So it's going to be a minus 5 at the end, and that's your final answer.
Wait, what?
All right, for the second one, we have this whole thing raised to the power of 3. Now, there are some rules dealing with how do we get that answer, but even if you don't know those rules, we can still get that, because cubing something means multiplying it by itself 3 times. So that would mean 2x to the 5th times 2x to the 5th times 2x to the 5th. It means multiplying it by itself 3 times. Well, what's 2 times 2 times 2?
It's 8 to 15.
It's 8.
Oh, 8. It's 8.
Yep. And so that gives me an 8. Now I have x to the 5th times x to the 5th times x to the 5th. Now when we multiply, remember that means we have to add our exponents. So in that case, I'm basically going to be doing 5 plus 5 plus 5, which is 15. So that gives me 8x to the 15th power. Okay, on to number 3. We're now going to multiply that x squared into both terms. We are distributing it to both terms. So x squared times 4x is going to give me 4, and then x squared times x is x cubed. Because remember, x is x to the power of 1. So I do the 2 plus the 1 to get that cubed. Then the minus stays a minus, and I do x squared times 10. Well, x squared times 10 is just 10x squared. And so then that's our final answer. It can't be simplified at all past that. Number 4. Again, we're adding them all together, so this is, again, just looking for like terms. And in this case, I have just 2 different types of like terms. I have an x to the 6 here, and I have an x to the 6 here. So I'm going to add those. So what is 1x to the 6 plus 2x to the 6? 3x to the 6.
That's the answer.
So we get 3x to the 6. And notice that the exponents have to be the same, and so they stay the same. That's a nice general rule for math. Anytime 2 things have to be the same in order to do it, it's because they're going to stay the same. Then we look at our x squareds. I have negative 3x squared plus 1x squared plus 2x squared. What's negative 3 plus 1?
2. Negative 2.
Negative 2. And then negative 2 plus 2 is? 0. So that means the x squared term just became a 0x squared, which means it went away. I don't need to write 0x squared, because that equals 0. And so then this 3x to the 6 is the final answer.
Oh, that's what I did.
All right, and finally, for our last one here, there's actually 2 different things we can do. On number 5 then, I think I'm going to start by distributing in the 3x. Now, it's not the only way you could have started, but it's the way I'm going to choose to start here. So if you do that, you should end up getting 3x cubed plus 15x squared minus 3x squared plus 3x. Now, that wasn't the way that I had to start that problem, because I could have also combined like terms. Well, now I have to combine the like terms in order to totally simplify it. Notice the like terms here are the x squareds. So the 3x cubed, it stays the same. But 15x squared minus 3x squared, that gives me 12x squared. It's positive, so it's a plus. And then the 3x, there's no like terms with that, so it stays a plus 3x. If you had chosen to combine the like terms here first, you would have gotten a 4x, and you would have multiplied that by the 3x to get the 12x squared. You could have done it in either order, and either order would have been fine. Today you're going to be continue to work with polynomials, but today's focus is actually going to be on classifying them and giving them the appropriate names. So, into your notes, you're going to copy that information. And so as you take a look at this information that you're putting into your notes, some details. This is considered classifying a polynomial by its degree. Now the degree is just the highest exponent of the polynomial. And if it can be simplified, yes, we have to simplify it first in terms of deciding what its degree is. So like if one of the terms disappears and turns out to affect what the highest exponent is, then we would consider that in deciding what its classification is. So, like if the highest exponent is 0, that is there's no x's in the equation at all, that is called a constant. So basically, that's just a number. So like 5 is a constant. If the highest exponent is 1, that means you just have an x in the equation. That's linear. Like 5x plus 3, that's linear. Because if you graph it, it gives you a line. And then we get into all these other classifications that you have been hearing about for a while. So like quadratic is anytime it's squared. A way to remember that is quad, like quadrilateral. Square is a quadrilateral, x squared. Might be a way to help remember that one. And cubic, quartic, quintic. And then after quintic, notice we just say degree 6, degree 7, or whatever. We're not going to worry about having a bunch of specific classifications past that, at least to actually memorize and know and use on a regular basis, just because they don't come up that often. All right, now using that information that you just wrote down, I'd like you please to classify each of these polynomials by their degree. Now as you write it on your paper, include both the original equation, or expression in this case, and its classification. So you're going to write down our expression, and then you're going to write down an answer like constant, or linear, or quadratic, and so on. And remember, you're looking for what's the highest exponent to decide that. So let's check in on the first one here. So in this case with number 1, what is the highest exponent in number 1?
Quadratic.
It is 2. The highest exponent here is the 2. That is considered to be the degree of the polynomial. And if it is degree 2, looking at your table, you can see that it is called quadratic. So number 1 is quadratic. All right, now on to number 2. Number 2, the degree is going to come from this term right here. Now what is the exponent here on x?
0.
On the x, this is x to the 1 power. Because remember, x to the 1 just equals x.
Oh my goodness.
And so since that is just x to the 1, that means it's degree 1, which means it is considered to be linear.
Linear? What? Boy, I can't believe it.
Okay, number 3.
Oh yeah, you'll end up like we're on a stall.
Number 3, we look for the highest exponent, and in this case our highest exponent is 4. If it's degree 4, what do we call it? Okay, so number 3 ended up being quartic because the highest degree was 4. Number 4, there is no x there. If the x is totally gone, what's the degree?
Constant.
It's degree 0, and so yes, we do call that constant.
Oh, I get it now.
And it's called constant because notice that whatever we tried to say that x equaled, it would always equal a constant, -3. It would always equal the same thing. And finally, in number 5, what is the degree in number 5? So number 5, at first we might think it's quintic, but remember that we actually have to simplify the expression first. And notice in this case, we have 2x to the 5th minus 2x to the 5th. That would become a 0. So if I simplified this, the whole thing would just equal 8x cubed.
So it's cubic?
So it's cubic, yes.
Oh,
What is degree 6?
Now, having done those, there's actually 2 different ways we classify polynomials. And so we also classify it by number of terms, so this 2 needs to go into your notes. So now we see that we can classify a polynomial by number of terms as well. The terms, and this you might also want to add in case you don't remember what the terms are the ones that are separated by addition and subtraction. So the parts of our polynomial separated by addition and subtraction here. And so if there's only one term, it's a monomial. Fairly straightforward, right? Mono means one. 2 is binomial, 3 terms is a trinomial, and again, anything past that, we just have a generic classification. So if there's 4 terms, we'd say it's a polynomial of 4 terms. Now we're going to do some examples of these again. To start with, please just write down number 6 here. Write down that expression, x squared plus 5x plus 6. And then I'm just going to walk through how we actually know what that classification is by its number of terms. And as I take a look at that now to classify it, I need to count the number of terms. And remember that terms are separated by addition and subtraction, so that means I have a term here, and a term here. So that means there's a grand total of 3 different terms. And if there's 3 terms, that means we call it a trinomial. So this one will be called trinomial. Repeat the process, please, for the rest of them. And yes, remember, if it can be simplified, you need to simplify it first in deciding that. All right, on to number 7. In number 7, we have one term because there's no addition or subtraction at all to separate anything. And so since there's one term, it is a monomial. Number 8, I count 5 terms at the start, but then I double check can any be simplified, and no they can't because none of them are like terms. So that means yes, there are 5 terms. If there's 5 terms, then we say polynomial of 5 terms.
Of 5 terms.
All right, then we go on to number 9. And in number 9, there are in fact 2 terms, so that one's going to be binomial. And finally, number 10, it looks like 4 terms, but there's actually not going to be 4 terms here because it does simplify. Because I see multiple x cubes here, so first thing I want to do is simplify. So I do 7 plus 1x cubed, so that's going to be 8x cubed. Minus 8x cubed, well, that goes away, so there's 0x cubes. All there really is negative 5x here. And negative 5x is a monomial. Now, having classified by both degree and number of terms, we now are going to do both. We're going to classify each of these by degree and number of terms. So to start with, please write down the expression for number 11, and then I'm going to walk you through how to do that first one. All right, so for number 11 there, when we classify by degree and number of terms, we always list the degree part first. So looking at number 11, you notice the highest exponent number is 2. And if it's 2, that means it is a quadratic. So the first thing I write then is quadratic. Now I classify by number of terms. I see 2 terms there. And so since there are 2 terms, remember separated by addition and subtraction, that means it is a binomial. So we call this a quadratic binomial. Repeat that same process for the other 4 to put all the pieces together. Okay, for number 12, you should be finding it is a degree 6 trinomial, because the highest exponent there is 6, and there are 3 terms. Number 13, it is just x. That's like x to the 1, so it's degree 1. That means linear. There's only 1 term, so linear monomial.
And what's that?
Okay. Number 14, you notice our highest exponent there is 3, so that one is cubic. There are 2 terms, so cubic binomial. And then for number 15, in number 15, we're going to simplify it first. Now a little side note here. One of the reasons why we want to establish this language is because it lets us talk about how we are multiplying a linear monomial by a quadratic binomial. But when we actually do that work, that is going to give us, as a simplified expression, 6x cubed plus x. And so then that is cubic. And there are 2 terms, so it is a cubic binomial.